Good morning. Today we are going to study quadrilaterals and parallelograms and all of the four different types of parallelograms. That's right, there are four kinds of parallelograms. So go ahead and take this time right now. I want you to copy down the flow chart to start. That way when I start to define the stuff, it'll be easier for you to write everything down. Okay, so first of all, let's start with quadrilateral. Why are you two smiling? Okay. I'm still on mute. Okay, so we're going to start with the definition of a quadrilateral. A quadrilateral is a four-sided polygon. There are two distinct branches that come off of quadrilateral. This trapezoid down here is down by itself because nothing else is related to a trapezoid. If it's a trapezoid, it can't be anything else. A trapezoid is a quadrilateral so by definition, since it's quadrilateral, it's four-sided. It's a quadrilateral with one set of parallel sides. So two of its sides are parallel, here and here. The other two, if we extended them, would eventually intersect. Trapezoid, really, it's what? It's a triangle with the top cut off, isn't it? Yeah. Right, so trapezoid is by itself. If it's a trapezoid, you're done. And we really don't talk about trapezoids much because they're a unique shape that doesn't have a lot of properties, or it's not really related to anything else. All right, so we'll spend the rest of the time talking about this right-hand side and all the different kinds of parallelograms. So remember, as we're working down, the way the flow chart works is you go to parallelogram, then down. As you work your way down, the shapes that are below parallelogram have all the properties of parallelograms plus extra. So what we're doing is we're going to define parallelogram. Then when we get to rectangle, we'll say it's a parallelogram plus this extra stuff that makes it a rectangle. So the square is the most restrictive or has the most properties to it. All right, starting with parallelogram. A parallelogram is a quadrilateral because it's four-sided with opposite sides being parallel and congruent. So opposite sides are parallel and congruent. That's what makes a quadrilateral a parallelogram. So in that, those two sides are congruent, these two sides are congruent. A rectangle. Now notice, when I start the definition, a rectangle is a parallelogram, which means that the opposite sides are parallel and congruent, but beyond that, a rectangle has one 90-degree angle. So the rectangle is a parallelogram with one 90-degree angle. Does anybody have a problem with that definition? Yeah, there's not one 90-degree angle, is there? There's four of them, right? Well, that's the thing about mathematicians and their definitions. They make you think. And it's annoying, but it is what it is. And you'll see why we only have to say one 90-degree angle on the next page. We'll talk about the properties of the angles and the diagonals of a parallel. We will come to this page. But one of the properties of parallelograms is that the opposite angles are congruent. Like that. And then if you take any two in a row, like here, these two, they're supplementary, so they have to add to 180 degrees. So going back to our rectangle, if this one is 90 degrees, the opposite angle has to be congruent. So if this one's 90, that one has to be 90 as well. And if any two consecutive angles are supplementary, you have to add to 180 degrees. Well, 90 plus what gives you 180? 90. So 90 plus 90 has to give you 180. That's why all four are right angles. But we only have to say one is a right angle because by definition, if it's a parallelogram, if you have one that's 90, all four of them will work out to be 90 because of the properties of the angles. Okay. Going off to the other side. Well, let me finish this. So definitely sides, opposite and congruent. Down here we have a rhombus. A rhombus is a parallelogram. Okay, rhombus. A rhombus is a parallelogram. So this is a parallelogram, which means the opposite sides are parallel and congruent. But this is a parallelogram with all sides congruent, not just the opposite. So all sides are congruent. It's like a square that's been tilted to the right or the left. So that's what makes a rhombus, not just a parallelogram, is that not only the opposite sides are congruent, but all four sides are congruent. Does that look like something maybe one of your elementary school teachers showed you, but they called it something else? No? Or how about if I draw it like this? Yes, I heard somebody whisper it. If I rotate it like that, this is the only time you're allowed to say it in this class. Go ahead and say it. What is that? A diamond. No. Diamond is geology. A diamond is a precious stone that comes out of the earth. It was once a lump of coal that over millions of years was compressed and turned into a little shiny little rock. This is a rhombus, but you might have been incorrectly taught this by one of your elementary school teachers. It is a rhombus. Okay, where are my baseball fans? Nobody? Oh, so why do they call it a baseball diamond? Because a baseball rhombus sounds funny. That's why. So that is a rhombus, not a diamond. I don't want to hear anybody calling it a diamond, or I may have to hurt you. All right, and finally the last one, a square. Is a square a rhombus? Yes. Is a square a parallelogram? Yes. Is a square a rectangle? Yes. It's everything. So what properties does a square have? It has all of it. Has all the properties. It has opposite sides, parallel and congruent. It has 190-degree angle. All four sides are congruent. It has everything. So a square is every kind of parallelogram there is. So there are four kinds of parallelograms: the basic parallelogram, the rectangle, the rhombus, and the square. Right, so those are the basic properties of quadrilaterals. Now specifically going into parallelograms, we have some properties for the angles and sides of parallelograms. So these are the properties of angles and sides of a parallelogram. The first one we already talked about. Look at angle A and angle C. They're opposite angles. And I said the opposite angles are, starts with the C, ends with congruent. Congruent. Yeah, so A and C are congruent angles. So the opposite angles in a parallelogram are congruent, which means that's true in a rhombus, that's true in a rectangle, that's true in a square. Your opposite angles are congruent. Now in a square and a rectangle, they're all congruent because they're all 90-degree angles. But so A and C, opposite angles. Opposite angles are congruent in a parallelogram. Now I'm going to talk about angles A and B. They're not the only ones, though. What I'm going to say is going to apply to angles A and B, A and D, C and D, and B and C. If these are two in a row, right? We call these consecutive angles. And in a parallelogram, the consecutive angles are supplementary. What does that mean? Yep, they add to 180 degrees. So if you take any two in a row and add them up, they have to equal 180 degrees. So if I wanted to know what all four angles, individual angles, were in a parallelogram, how many would I have to be given? How many measures? Well, if I'm given all four, yes, I'm going to know what all four are. Thank you, Captain Obvious. That would definitely be the easiest way to know what all four is if I were given all four. But what's the minimum? How many do I have to be given? 1, 2, 3, 1. Right. If I'm given 1, I can figure out the other 3. And we'll do that on the next page. So that's all I have to be given. To figure out the other 3 angles, I only have to be given the 1. Yes? What? You can't see? Okay. Sure. And what can we say about sides AB and CD? They are congruent because the opposite sides of a parallelogram are congruent. So those two are congruent, and so are those two. AB is congruent to CD, and BC is congruent to AD. The opposite sides are congruent. These are actually in your book listed as properties. There's like 5 of them. I'm just giving the properties to you. I'm not actually listing them out. They're on pages 216 and 217. The first 4 have to do with the properties of parallelograms. The next 3 we'll get to in a couple pages. Alright, what can we do with the information we have so far about the angles and the sides of a parallelogram? Well, I mentioned how many angle measures do you need to be given to figure out all 4? Just one of them. So if I know that the measure of angle D is 60, what's the measure of angle F? 60. How do you know that? The opposite angles in a parallelogram are congruent. So if D is 60, F is also 60 degrees. Well, if D is 60, what's E and G then? What are E and G? Okay, not everybody at once. I can't. Yeah, what do D and E have to add up to? 180, because consecutive angles are supplementary. So if D is 60, what's E? 120. Now you can get G by saying, okay, E and G are congruent because they're opposite angles, or you could say 60 plus G have to equal 180. So either way. But either way, you get that those two are 120 degrees. So that's 120, and that one is 120. So that's how we figure it out, and that's why I said, in order to find the measure of all four angles in a parallelogram, I only have to be given one, because I can use that opposite angle congruency, and the consecutive angles are supplementary. All right, the next three properties about parallelograms cover the diagonals of the parallelograms. So this shape here in the upper left, this is a parallelogram. And the diagonals of a parallelogram bisect each other. Now what does it mean to bisect something? It means to cut it into two equal parts. So this one here is bisected. That means that section is congruent to that section. And this section is congruent to that section. They are not necessarily congruent to each other. They're usually not. The two larger ones. So that's true about a parallelogram. They bisect each other. They're diagonals. This next shape is what? This would be a rectangle, right? The diagonals of a rectangle are congruent. That means I get all four sections being also congruent to each other because they bisect each other, because a rectangle is a parallelogram, so that property is still true in a rectangle. So the entire lengths are congruent to each other, which means if they are also bisected, because this is also a parallelogram, that means the individual sections, they're all four congruent to each other. So this is what makes this a little complicated, is that you get the most basic definition for parallelogram, but then you have to apply all that stuff also to the other shapes. So rectangle has that they are bisected plus they are congruent. Now this is a rhombus. This doesn't have any of the rectangle stuff. It just has the parallelogram. But in addition to having that they bisect each other, because a rhombus is a parallelogram, which means their diagonals bisect each other, the rhombus has something else. The rhombus has that the diagonals are perpendicular. Now because they're perpendicular, what does that mean about the angles here in the middle? They are and 90 degrees, right? They're all right angles. So with the rhombus, you have four right angles in the middle, like that, because the diagonals of a rhombus are perpendicular. So they bisect each other because a rhombus is a parallelogram, but in addition to that, they're also perpendicular. So they're 90-degree angles formed at their intersection. And that last shape, of course, is a square. And what does the square have? It has all of it, just like on the first one. It has all of it, which means the diagonals bisect each other. The entire diagonals are congruent, which means all four sections are congruent, just like the rectangle. It also has the properties of a rhombus, because the square is also a rhombus, which means that in the middle, where they intersect, I have four right angles formed. Right there. So a square has all of the properties. So that covers the 5 properties of quadrilaterals. I just worded them differently and gave you visual examples. What can we do with this? We can solve problems like these. In parallelogram ABCD, so I know it's a parallelogram. So I know that that section is congruent to that section, and that line segment is congruent to that line segment. Because it's a parallelogram, the diagonals bisect each other. Okay, so in parallelogram ABCD, diagonals AC and BD intersect at E. They're stating just the obvious. If AE, right here, if that equals 5x minus 3, its length, and EC, that section, is 15 minus x, I want to try and figure out now what's the length of the entire line, AC. Well, because they're diagonals that bisect each other, and they're congruent, what do I know about their lengths right here? They are equal. That means I can set those two equal to each other and solve for x. And what would I do first? Add my like terms. So I need to add x to both sides to move x from the right to the left. That will cancel. 5x plus 1x is 6x minus 3 equals 15. Now what? Add 3. 6x equals 18. Now what? Divide by 6. I divide by 6 and I get x equals 3. Am I done? Is that my answer? The length is 3. What do I do with x now? What? Huh. Don't you plug it in? Thank you. Plug it in. Now, you could plug it into both sides. You don't need to since these two have to be the same length. I'm going to plug in right here at 15 minus x. So I get 15 minus 3 is 12. That means the length of each one of these sections is 12, which means the length of AC is 24. I've now solved that by using, that's analytical geometry. That's what we do in here. How would I solve this letter B? What process would I follow? The same one, yeah. So we'd solve it the same way. Same as A. Okay. 1 to 29 and 33 to 44 all. This will be due tomorrow. 1 to 29 and 33 to 44 all. On pages 218 and 219. Pages 218 and 219.